45 years into its journey, Voyager is now sending alarming signals back to Earth. For more than 4 decades, Voyager 1 and Voyager 2 have been quietly drifting further and further from Earth, becoming the most distant human-made objects in space. These twin spacecraft were launched in 1977, and their initial mission was to study the outer planets of our solar system. However, as of today, they have ventured far beyond their original destinations, breaking boundaries and entering interstellar space, where no other human-made object has ever traveled. Yet now, after 45 years of unprecedented exploration, these technological marvels are sending back worrying signals to Earth, signaling that their long and illustrious journey might be coming to an end. As the spacecraft continue to hurtle through the cosmos, these alarming signals have caught the attention of scientists, engineers, and space enthusiasts around the globe. What exactly is happening? Could this be the end of the Voyager mission, or just a temporary setback? In this article, we'll dive deep into the origins of the Voyager mission, their extraordinary achievements, the challenges they now face, and what these distress signals might mean for the future of one of humanity's greatest space exploration endeavors. The birth of the Voyager mission, a bold new era. The 1970s marked an era of immense scientific curiosity and exploration in space. NASA, buoyed by the success of the Apollo missions, sought to further explore the outer reaches of our solar system. Voyager 1 and Voyager 2 were designed as twin spacecraft, identical in construction, tasked with the ambitious goal of exploring Jupiter, Saturn, Uranus, and Neptune. This mission was initially expected to last 5 years. The timing of the Voyager launches was significant, capitalizing on a rare planetary alignment that occurs only once every 176 years. This alignment allowed both Voyager spacecraft to use the gravitational pull of the planets they encountered to slingshot toward the next destination, a maneuver known as a gravity assist. The success of this technique would allow the Voyagers to visit multiple planets in one mission, all while conserving fuel and extending their operational lifespans. On August 20, 1977, Voyager 2 was launched from Cape Canaveral, Florida, followed by Voyager 1 on September 5 of the same year. Despite its later launch, Voyager 1 followed a faster trajectory and quickly overtook its twin, eventually becoming the farthest human-made object from Earth. These spacecraft carried with them cutting-edge technology for their time, including cameras, plasma detectors, magnetometers, and a variety of other instruments designed to analyze the planets and their moons. Yet, while NASA scientists were hopeful that the Voyagers would last through their primary mission, no one could have predicted the incredible journey that would follow, one that would extend well beyond the outer planets, into the uncharted realms of interstellar space. The Grand Tour, discoveries that redefined our solar system. Voyager's initial objective was the study of the gas giants, Jupiter and Saturn. Voyager 1 arrived at Jupiter in March 1979, followed by Voyager 2 in July of the same year. These encounters were nothing short of revelatory. The spacecraft sent back breathtaking images of Jupiter's swirling storms, including detailed observations of the Great Red Spot, a massive hurricane-like storm that has been raging for centuries. Even more astonishing were the discoveries made about Jupiter's moons. Voyager 1's close flyby of Io revealed the first evidence of active volcanism on another celestial body. Io, with its sulfur-spewing volcanoes and molten landscapes, became a centerpiece of planetary science, showing that moons could be just as geologically active as planets themselves. Voyager's journey continued to Saturn, where both spacecraft transmitted unprecedented images and data back to Earth. They provided new insights into Saturn's famous ring system, showing that these rings were far more complex than anyone had imagined. Voyager 1 also conducted a close flyby of Saturn's largest moon, Titan, revealing a thick atmosphere composed primarily of nitrogen, a potential environment for prebiotic chemistry. While Voyager 1's trajectory took it out of the plane of the solar system after Saturn, Voyager 2's path was extended to include Uranus and Neptune, the two most distant planets in our solar system. In 1986, Voyager 2 made the first, and only, close encounter with Uranus, unveiling its tilted magnetic field and discovering 10 new moons. 3 years later, in 1989, Voyager 2 reached Neptune, where it discovered supersonic winds and the moon Triton, with its icy geysers. These planetary encounters not only fulfilled the primary mission objectives, but also revolutionized our understanding of the outer planets and their moons. Voyager's instruments revealed an unexpectedly dynamic and diverse outer solar system, challenging many preconceptions held by scientists at the time. The extended mission, venturing into interstellar space. By the time the Voyager spacecraft completed their flybys of the outer planets, they had already exceeded their expected lifespan. However, both spacecraft were still functioning, and NASA extended their mission to include the exploration of the outermost reaches of the solar system, the heliosphere, and beyond. The heliosphere is a vast bubble of charged particles emanating from the Sun, creating a protective shield around the solar system. Outside this bubble lies interstellar space, the region between stars, which is filled with cosmic rays, dust, and plasma. Understanding the boundary between the heliosphere and interstellar space was a primary objective of the extended Voyager mission. In August 2012, after 35 years of continuous travel, Voyager 1 crossed the heliopause, the boundary marking the end of the Sun's influence and the beginning of interstellar space. It became the first human-made object to do so, a historic achievement that marked humanity's first steps beyond the solar system. Voyager 2 followed suit in November 2018, also crossing the heliopause and entering interstellar space. These milestones were more than symbolic. They provided the first direct measurements of the interstellar medium, offering critical insights into the nature of the space between stars. The Voyagers measured cosmic rays, magnetic fields, and the density of particles in interstellar space, providing valuable data that could not be obtained by any other means. The alarming signals. What do they mean? As of 2023, both Voyager spacecraft remain operational, continuing to send data back to Earth. However, the alarming signals now being received by NASA's Deep Space Network, DSN, indicate that the Voyagers are facing significant challenges as they journey deeper into interstellar space. In May 2022, NASA engineers first reported an anomaly with Voyager 1's Attitude Articulation and Control System (ACS). This system is responsible for keeping Voyager 1's high-gain antenna pointed toward Earth, ensuring that it can maintain communication. The ACS began sending back erroneous telemetry data, indicating that the spacecraft's orientation was not being reported accurately. Curiously, despite this data anomaly, Voyager 1's antenna remained correctly aligned, and the spacecraft continued to transmit data back to Earth. The source of the anomaly remains unclear, but engineers suspect that it may be the result of aging hardware. After 45 years in space, the Voyager spacecraft are far beyond their intended lifespan, and many of their systems are showing signs of degradation. The harsh conditions of interstellar space, combined with the decreasing power levels available to the spacecraft, are putting immense strain on their aging components. Similarly, Voyager 2 has also exhibited signs of wear and tear, with engineers noting increasing challenges in maintaining communication and power levels. Both spacecraft are powered by radioisotope thermoelectric generators, RTGs, which convert heat from the decay of plutonium-238 into electricity. However, the power output of these RTGs has been steadily declining since launch, and the spacecraft now operate on only a fraction of the power they once had. NASA has been carefully managing the remaining power on both spacecraft, turning off non-essential systems and instruments to conserve energy. However, as the power levels continue to decline, it will become increasingly difficult to maintain communication with the spacecraft and operate their scientific instruments. The warning signals sent by the Voyagers are a clear indication that the spacecraft are nearing the end of their operational lives. While engineers are working diligently to troubleshoot the issues and keep the Voyagers operational for as long as possible, it is becoming increasingly clear that their remarkable journey may soon come to an end. The challenges of interstellar space. The environment in interstellar space is vastly different from the space within our solar system. Beyond the protective bubble of the heliosphere, the Voyagers are exposed to higher levels of cosmic rays and radiation. The density of particles is also much lower, making it more difficult for the spacecraft to maintain their systems and operate effectively. One of the most significant challenges the Voyagers face is the extreme cold of interstellar space. Temperatures in this region can drop to just a few degrees above absolute zero, putting additional strain on the spacecraft systems. While the Voyagers were designed to operate in the cold vacuum of space, they were not specifically designed for the frigid conditions of interstellar space, and this may be contributing to the degradation of their systems. Another challenge is the vast distance between the Voyagers and Earth. As of 2023, Voyager 1 is more than 14 billion miles, 22.5 billion kilometers, from Earth, while Voyager 2 is approximately 12 billion miles, 19.3 billion kilometers, away. The sheer distance makes communication increasingly difficult, with signals taking more than 20 hours to travel from the spacecraft to Earth and back. The faint signals received by NASA's DSN must be carefully amplified and analyzed to extract meaningful data, and any misalignment of the spacecraft's antenna could result in a loss of communication. In addition to the power and communication challenges, the Voyagers are also contending with the gradual degradation of their scientific instruments. While many of the instruments have already been turned off to conserve power, those that remain operational are showing signs of aging. For example, the Cosmic Rays Subsystem, CRS, on both spacecraft, which measures high-energy particles from the Sun and interstellar space, has been providing valuable data for decades, but its sensors are now showing reduced sensitivity. The legacy of Voyager, a mission for the ages. Despite the challenges they face, the Voyager spacecraft have already secured their place in history as one of humanity's greatest space exploration achievements. Their journey through the solar system and into interstellar space has expanded our understanding of the cosmos and inspired generations of scientists, engineers, and space enthusiasts. Voyager's greatest legacy may be its role as a pathfinder for future interstellar missions. The data collected by the spacecraft is helping scientists better understand the conditions in interstellar space, which will be critical for the design of future missions to explore beyond the solar system. One of the most iconic aspects of the Voyager mission is the Golden Record, a phonograph record attached to both spacecraft that contains sounds and images from Earth, intended as a message to any extraterrestrial civilizations that may encounter the spacecraft millions of years from now. The record includes greetings in 55 languages, music from around the world, and natural sounds such as birdsong and ocean waves. The Golden Record represents humanity's desire to reach out to the stars and share our culture with the universe. The legacy of Voyager is not just about the data it has collected, but about what it represents: the spirit of exploration, curiosity, and the desire to push the boundaries of human knowledge. Looking ahead, the future of space exploration. As we contemplate the end of the Voyager mission, we also look to the future of space exploration. The lessons learned from Voyager will inform the design of future spacecraft that will venture even further into the cosmos. One such mission under consideration by NASA is the Interstellar Probe, a spacecraft that would be designed to travel much faster than Voyager and reach interstellar space in just a few decades. Advances in propulsion technology, such as solar sails and nuclear propulsion, could enable spacecraft to travel to nearby star systems, opening up new possibilities for exploration. The success of the Voyager mission has also inspired the search for exoplanets, planets orbiting other stars, and the quest to find life beyond Earth. Missions like the James Webb Space Telescope and the Plan-Louvois Large UV/Optical/IR Surveyor telescope are designed to study exoplanets in detail, searching for signs of habitable environments and potential biosignatures. While the Voyager spacecraft may soon go silent, their journey will continue to inspire future generations of explorers to reach for the stars. The warning signals they are sending back to Earth are a reminder that space exploration is fraught with challenges, but it is also a testament to the resilience and ingenuity of the human spirit. Conclusion: a farewell to Voyager? As Voyager 1 and Voyager 2 send back distress signals after 45 years of space exploration, it is clear that their remarkable journey is nearing its end. These spacecraft, which were originally designed for a 5-year mission to explore the outer planets, have far exceeded expectations, traveling beyond the solar system and becoming the first human-made objects to enter interstellar space. The challenges they now face, the degradation of their systems, the loss of power, and the extreme conditions of interstellar space, are reminders of the immense difficulty of space exploration. Yet, despite these challenges, the Voyagers have accomplished more than anyone could have imagined. Their legacy will endure, not only in the data they have provided but in the inspiration they have given to future generations of explorers. As we prepare to say farewell to Voyager, we are reminded that the spirit of exploration is at the heart of what it means to be human. The Voyagers may be sending distress signals, but their journey is far from over. Their legacy will continue to inspire us to reach for the stars and push the boundaries of what is possible.